In this video, we're going to look at two examples to do with the sine rule. Here's our first one. So we're trying to find the length of little x. So if that is big X on down the bottom left-hand corner, then this must be little x, right? From our naming convention. We know we're going to use the sine rule because we've got two angles and a side length, if we remember that. Now, what we can do, seeing as we have these two angles, we can get, if we think about, x on sine of x, well, what else do we know? We know a lot of stuff about z. We know the size of the angle and the side length. So why don't we say is equal to z on sine of z? We're just going to pick to look at those two. Now, it'll be handy to know what the value of big X is, the angle, and we can just work it out by looking at the other angles, right? So if we do 195 plus 40, we're at 135. So to add up to 180, we need 45 degrees in here. So now we've got X, big Z, and little z, so we can set up our equation. So we just sub in, so sine of 45 is equal to, what was it, 4 on sine of 40. And now we just need to rearrange for x. So x is sine of 45 degrees times 4 on sine of 40. So sine of 45, that is one of our exact values actually, it's 1 over 2. And then the rest, well, we've got sine of 40, not an exact value, we're going to have to use a calculator here. I'm just going to use a scientific calculator. So putting in, so x by itself was 1 on root 2 times by 4 on, just go, let's put the 4 at the top there, and we'll put the sine of 40 here. And there we go, we get 4.4 centimeters, thereabouts. And now let's just check that got the same thing. Yep, very good. So that's that example, pretty straightforward. Just label things, take out what you know, and you should get there pretty quick. Here's a more challenging example. It's more challenging partly because there's no diagram for you. So you've got to draw the triangle yourself. Now, so what I do is I first read it carefully. A triangle PQR has angle Q equals 39 degrees, R equals 41, and Q equals 28. What is the value of angle R? So what I do is when I draw these, I try and do it roughly to scale, right? So 40 degrees, it's a bit less than 45, so it looks something like that, right? So that must be Q. I've got it being 39 degrees. Then R is 41, Q is 28. So the other side is going to be Q. So why don't we just extend this a bit and then drop that there. And we'll call what? So little r is the longer one. So this must be big R. This must be little r of 41. And this must be P. And so little, oh, actually we're told little q is 28. Whoops. Oh well, that's fine. That looks reasonable. 41 is bigger than 28, so that looks about right. We want to find the angle R. We're going to find this angle here. So what do we know? We know a lot about Q. So we want to get, we can use the sine rule by going sine of R on R is equal to, well, we know a lot about Q, so let's use the stuff about Q. Sine of Q on Q. Now, we don't know sine of R, but we do know little r. Little r is 41, and sine of Q is, so the angle Q is 39 degrees, and little q is 28. So sine of R is going to be 41 times sine 39 on 28. Let's just chuck that in our scientific calculator again. So we get 41 times by sine of 39 all over, well, doesn't matter too much, does it? But that looks about the same, doesn't it? So we get 0.922, let's call it. Okay, so if we want to get r, what we can do is we can do inverse sine of 0.922. So we can just go back to our scientific calculator and let's press enter, and then we'll go, can we do inverse sine on this? Let's have a look. Function, inverse sine, let's just go up and grab that. Nope. I'll just copy and paste, Control C, Control V. And we get 67.147. So I'm just going to write that maybe up here. We've got R is equal to 67.15, let's call it degrees. Now, that is an answer. And so R could certainly take that value of 67.15 degrees. If we look at my drawing though, that doesn't really look right, does it? That looks, it looks a bit like 90 degrees, maybe a bit more than 90 degrees. It looks like an obtuse angle. And that is an acute angle. Now the reason why it looks like my triangle doesn't work is because of something that is special to the sine rule. If you think about your unit circle, a circle of radius 1, just use your imagination that that actually is a circle. Well, we've said that the sine of r is 0.922. That means that the y value on a unit circle is somewhere up here, right? Of 0.922. Now, so the 67 is about there, right? That is what your scientific calculator is going to tell you, 67.15 degrees. But if you think about it if you know your unit circle well, there's another angle out here, right? Where that is going to be bigger than 90 degrees, an obtuse angle. And the easy way to get that is, well, it should be that this angle in here should also be 67.15. So our other angle will be 180 take 67.15. So what's that going to be? Just change to a pen. So we've got 180. Take away 67.15, and we get 112.85 equals 112.85 degrees. And so that looks a bit more like what this is in terms of my drawing. But so what this is showing us is that for some cases of the sine rule, for some angles, I'm just going to delete all this writing, and I'll show you on the next slide, you can actually get two different triangles. So here is the one where you've got R being 67.1, but you can also have this triangle with the obtuse angle, the one that probably is more likely what I drew, where it's a bigger one. And